Welcome to the first lesson in Session 7 on simplifying rational expressions. A rational expression is a fraction that contains polynomials as the numerator and or in the denominator. Now, since we're working with a fraction, we need to review how to simplify fractions. So when we're simplifying fractions, keep in mind that we divide out the greatest common factor of the numerator and the denominator. So the correct way to do this is to take the numerator and the denominator and break them down into prime factored form. So the prime factorization of 10 is 2 times 5. The prime factorization of 15 is 3 times 5. Now we're in a position where we can cancel out the 5's, leaving us with 2/3. Notice we factor first and we canceled out the greatest common factor. An easy mistake to make when simplifying rational expressions is to cancel out numbers that are being added or subtracted. So take a look at this fraction and see how incorrect it is to cancel out terms that are being added or subtracted. 10 can be rewritten as 1 plus 9. 15 can be written as 6 plus 9. However, you cannot then cancel out the 9's, leaving us with a value of 1/6. And the reason is we cannot cancel our terms that are being added or subtracted. We have to factor first and cancel out the greatest common factor. The greatest common factor are numbers that are being multiplied, not added or subtracted. So when simplifying rational expressions, we completely factor both the numerator and the denominator, and then look to divide out some common factors. We cannot cancel out terms that are being added or subtracted. So we start with some examples, and we're going to start simplifying some monomial fractions. So with monomials, you just have a single term. So there's nothing being added or subtracted. Everything in each term in the numerator and the denominator is being multiplied and is fair game to cancel out. So in the first example, we have 24x to the 13th y to the second over negative 16x to the 13th y. So with 24 and negative 16, you have a greatest common factor of 8. X to the 13th divided by x to the 13th is going to cancel out. Y to the second divided by y leaves us with y to the first in the numerator. So our answer is negative 3y over 2. In the next example, we have a to the second m to the third t to the sixth over a to the fifth m to the seventh t to the negative fifth. So we start with the a's. There's 3 more a's in the denominator than there are in the numerator. There are 4 more m's in the denominator than there are in the numerator. And the difference between positive 6 and negative 5 is 11. So there are 11 more t's in the numerator than there are in the denominator. So our answer is t to the 11th over a to the third m to the fourth. Now we move on and get to some polynomials. In the first example, we have 2x plus 18 over x to the second plus 11x plus 18. We have to factor first. We cannot cancel the 18's out. We cannot cancel any x's out. We cannot do anything until we factor first. 2x plus 18, those two terms are being added. X squared plus 11x plus 18, there's 3 terms there. We need to factor first before we think to cancel. So factoring the numerator gives us 2 times the quantity of x plus 9, and factoring the denominator gives us the quantity of x plus 9 times x plus 2. Now we can see x plus 9 is the greatest common factor. We cancel that out, and that leaves us with 2 over the quantity of x plus 2. In the next example, we have x to the third minus 9x over x to the second minus 6x plus 9. So we always have to start by factoring first. Factor in the numerator completely gives us x times the quantity of x plus 3 times the quantity of x minus 3 over the quantity of x minus 3 to the second power. So x minus 3 is our common factor. When we cancel that out, we get x, the quantity of x plus 3 times the quantity of x minus 3. In our next example, we're going to experience some opposite factors. Since subtraction is not commutative, we must sometimes divide out a -1 to put ourselves in position to factor. You see in the first example, we have 7x minus 8 over the quantity of 16 minus 14x. So the numerator is prime, there is no common factor. However, we're going to divide out a -2 from the denominator, giving us -2 times the quantity of 7x minus 8. Now we identify the greatest common factor from the numerator and the denominator is 7x minus 8, leaving us with -1/2. In the next example, we can factor out a -2 or a -1 from the numerator, rewriting our numerator as the opposite of the quantity of 4x squared minus 9. Now we have a difference of squares. It's the same order as the denominator. So 2x plus 3 times 2x minus 3 over 2x minus 3 times 3x plus 2. So our common factor is 2x minus 3. When that gets canceled out, we're left with negative 2x plus 3 over 3x plus 2. In the next example, we're going to factor by grouping in the denominator. So the numerator is a difference of squares. Factor by grouping in the denominator. Continue to factor by grouping in the denominator as we have a difference of squares. And now we cancel out all of our common factors. So you can see an x plus 1 can get canceled and an x minus 1 will get canceled, leaving us with 1 over x plus 3. So we have to completely factor. Sometimes that means factoring multiple times. So here we had a difference of squares, we have factor by grouping, and then we had another difference of squares showing up in the denominator. In our last example, we've got 3x to the second plus 6x minus 24 all over 8 minus 2x minus x to the second. So we're going to divide a -1 out of the denominator, and we're going to factor the 3 out of the numerator. As you can see now, that leaves you with the common factor being the trinomial x squared plus 2x minus 8. When we cancel that out, we're left with -3. And that wraps up the lesson for today. Good luck on the quiz, and please email us if you have any questions.